Hi, welcome to PSL Demo Day. I'm your host, Jason DeBacker. Today, I'll also be the presenter. I'm going to share some recent work Rick Evans and I have done on the OG core model, which allow flexible parameter inputs, which can be used for some really interesting policy simulations. I'm going to focus on things that are time-varying parameters and how those can be used to simulate various interventions, such as things that affect health and mortality, as well as things that affect worker productivity. But there are other extensions I'll note as well. Let me bring up some slides to share. All right, so I'm going to, again, focus on some recent changes to the OG core model. In that model, and I'll share a link to that model in the YouTube video notes. In that model, there are kind of 4 age-specific parameters that we also now allow to be time varying. Those include mortality rates, fertility rates, worker productivity, and the disutility of labor supply that enters the household's utility function. We also have other time-varying parameters in the model, such as total factor productivity, which can vary over time and across production sector. And then, of course, all of the tax and benefit parameters in the model are allowed to vary over time, so you can model transitory policy. The tax and benefit parameters have been flexible for some time because that's a key focus of the model. But what's new in these last few weeks is the ability to have time-varying mortality, fertility, and productivity related parameters. And so that's what I'm going to highlight here today. So first, just a quick picture of what mortality rates look like in our model under at least one calibration of model. And what we're seeing here are the mortality rates. So this is the conditional probability of not making it to the next age calibrated to US data. So kind of if we're looking at anybody under the age of 50, there's a very low rate that you don't make it, conditional on, say, making it to age 50. There's a very small chance you won't make it to 51. That rises much more steeply past the age of 80. And then in our model, we're capping a lifetime at 100. So you might die before you reach 100 as an agent in our model, but at 100, it's kind of game over. And so that's the just arbitrary shoot up to 100% mortality rate going from 99 to 100. So those, again, vary by age. What's new is we're going to allow these mortality rates to vary over time. That's an update to the demographics module, and I'll talk a bit more about how that module has been updated shortly. But by allowing mortality rates to vary over time in the model, one can simulate things like the impacts of interventions such as maybe the reduction of exposure to lead in pipes, or reductions in pollutants, right? These things could have benefits to mortality rates. And so you could think about shifting these mortality rates over time as that technology, say to clean the air, becomes better. Okay. In addition, we've had for some time heterogeneity in worker productivity in the OG core model. That's displayed here, where different individuals of different skill groups have different earnings profiles. You can see the very highest earning group, the top 0.01% of earners over their lifetime. Their productivity profile here is very steep, peaking at in the mid-50s and then declining from there, showing that hump-shaped profile of productivity over one's lifetime. Okay, you kind of gain experience, you become a more productive worker, but at some point that cognitive decline catches up with you and you become less productive over time. All right, and then of course there's differences across these earning groups in terms of their productivity profiles, how they're shaped over their lifetime, and then as well as the level of those profiles. That's what generates income inequality and subsequently wealth inequality in our model. All right, but these worker productivity profiles as well, we can think about those might change over time if we were to make investments in, say, education, or again, you can think about also health interventions like the lead pipes example I used previously for mortality, probably more so applies to worker productivity. Right, if we can reduce exposure to lead pipes, we can increase cognitive capacity. That's going to affect these life cycle earnings profiles of different income groups. Okay, so if we think about those types of interventions, we want these things to change, these productivity profiles in this case to change over time, all right? And that's what new enhancements to the OG core model allow for, right? So I'll present just a couple very stylized simulations of how this can be used, and you'll note that some of these interventions have very large impacts on the economy. Okay, so I'll look at two things here. One, I'm going to think about shifting mortality rates. So a decrease in mortality rates. Let's assume this happens or takes some time to happen. So what I'm looking at here is in 2060, we've kind of fully benefited, say, from the reduction in air pollution with this shift out in mortality rates, okay? This is representing just a small shift in mortality for those older individuals, with the red dashed line representing this counterfactual simulation of a reduction in mortality rates. The next thing I'll present some macroeconomic results for is a shift in worker productivity. Again, think about the reduction in exposure to lead for individuals. That's going to make their cognitive capacity higher and shift their productivity profile. Here we're having it just affect those past age 40, and you can see the shift out with the dashed line, quite notable in the very top group, but it's happening in the other lifetime earning groups as well. That shift in productivity, again, will transition in over time. And here we have it affecting the economy fully in the year 2060. But that's a parameter one could play with OG Core now, is you can have these effects, this change in worker productivity, phase in over time, hit immediately, or hit many decades later. Now, again, OG Core is set up to look at macroeconomic effects of these types of policy interventions. So here I'm presenting just a few, again, a few types of results we might look at. We might care about wages and GDP as well as government revenue. And here we have it for those shift in mortality rates from the picture 2 slides ago. So this is changes in macroeconomic aggregates from 2054 through 2063. This is as kind of the initial 10 years as this mortality rates shift begins to occur. Numbers are presented in trillions of dollars. So we can see in terms of GDP in 2054, kind of first year there's any reduction in mortality, we're getting a small decline of about 130 billion in GDP. But as we kind of work through the timeline, as this policy phases in more, or excuse me, as this counterfactual phases in more, you can see those effects on GDP start to grow. And over the next 100 years, from 2024 to 2124, that increases GDP by about 17 trillion, that small shift in mortality. What's going on there is we've got workers who are living longer, but also we've got changes in the economy as well. So we've got this decline in GDP initially, but then that rises as we go through the time path. And again, over the next 100 years, a gain of about 17 trillion in GDP in terms of in net present value. What's interesting too is we've got these population dynamics going on. As people can live longer, that's going to increase the age distribution of the population. People are going to be slightly older. Also increases the size of the population. So that's really what's driving the GDP growth here, is we have more people able to produce more goods and services. Interestingly, you can see government revenue here. We haven't done anything to change the current social security system. And you can see government revenues declining. Here, this is net revenue, net taxes, net of social security, retirement insurance payouts. And that government revenue is declining, again, reflective of the relatively older population. So we're losing about not quite 3 trillion in government revenue as a result of increasing people's expected lifetime. The next simulation is for representing that shift in productivity. Again, think of an example like investing in education or reduction to environmental factors that decrease cognitive ability. All right. That small shift in worker productivity has large effects, making workers more productive, increases wages, increases the economy's output. And over the next 100 years, this is kind of turning into this small shift in productivity here, representative of about a 1-year increase in human capital of individuals, is shifting, increasing GDP by about 32 trillion in net present value terms. And here, government revenue going up. In this simulation, we just held the demographics constant, so we just have more productive workers now producing more output, and therefore tax revenues are increasing. Okay, so those were just a couple simple simulations, just to really illustrate. Again, we didn't put, I wasn't specific what the numbers used, other than kind of the 1 year shift in human capital. But the interesting thing here is we can have policies that phase in over time and affect demographics or worker productivity. We can measure the macroeconomic impacts of those policies. Again, they could be anything from environmental policies to education policies, or obviously many other types of policy interventions. So after having seen those results, I'll spend a little time going into the Python API for the OG core model and kind of drive through the demographics module to show you how that's working. Okay, here we are. I'm sharing the homepage for the OG core repository. All right, and so one of those new things Rick and I have done in the last few weeks is to bring the demographics module that was in each specific country calibration, so in OGZAF for South Africa, in OGUSA for the United States, and take those demographic modules out of each of those country calibrations and bring them into OG Core. And why we did that is because we found that the UN population projections data portal was just so robust. We could find any country with the same format of data, and it was identical in terms of the current data, or better than what we were finding for each of those countries individually in terms of coverage of these different metrics that are important for model inputs. So that is fertility, mortality, and the population distribution. So, since we ended up using the UN data portal in each of those countries, we just brought that module into OG Core and now allow users to specify what country do you want to pull the demographics from. Okay, so now if we look in the OG Core package repo, there's going to be the demographics.py module there. And we pulled it out of each of those country repos. And what's going to be different for each country is just the country code you pass. Okay, so we're going to have it default to the US here, because that's most often the economy we've been simulating, but it is in each of the functions in this module. The country ID is just something that the user can specify. So they can pull UN data from whichever country they're interested in. Okay. The UN data also offers, I guess, projections. In fact, a number of projections. So the UN population prospects data portal provides not just the current population, but UN demographers' forecasts of what they think the populations will be in these different countries over time, what they think the fertility rates will be over time in these various countries, and so forth, currently up to the year 2100. But you can get from the UN data portal time-varying fertility rates or time-varying mortality rates for each of these countries. Up until several weeks ago, that wasn't something that one could use in the OG core model, or or the models that depend upon it, like OGZAF and OGUSA. Now we're allowing these population parameters like fertility and mortality to vary over time. And so we can utilize, if one wanted to, those UN forecasts. Another thing we've added here, though, is that we've made it very flexible to input your own custom population forecast. So we've modified kind of the workhorse function in this module was this get pop objects function. And we've modified that substantially to allow the user to have a lot of flexibility. So one can put in, if they wish to, their own forecast of fertility rates, or their own forecast of mortality rates, including infant mortality rates, or their own forecast of immigration rates, or any combination of those, or none of those. If you choose none for any one of these different demographic inputs, the model will revert to using the UN data and their forecasts of these over time. But if you like, you can input your own forecast, okay, or check alternatives to the UN forecast. So this is really flexible to, by default, work with the UN population data, but also allow the user the flexibility to input their own custom demographic parameters. Okay, so this is offering a lot of flexibility, and this is how we're able to look at those population demographics that shift over time, fertility rates, say, decreasing over time or mortality rates decreasing over time. And the get pop objects function plays a great role in making this easy for the user because it's going to ensure that those are consistent and that the population distribution that is used in OG Core is consistent with the fertility or mortality rates that the user inputs. Okay. It's also going to ensure that there's a steady state population that's found from those inputs. Okay. So we do have to ensure that at some point the fertility rates stop changing or the mortality rates stop changing. And that's going to be a parameter essentially the user will define implicitly when they enter their own custom fertility or mortality rates, or if they're using the UN data, they can define it by choosing the last year of those UN data they would like to use. Okay, so that's a brief overview of these changes to the demographics.py module that are helping to affect what users can do with OG Core, such as having those time-varying mortality rates, right? We've, again, also made changes to OG Core in terms of updating the parameter space for productivity-related parameters, like the workers' hourly effective labor units. Those are the productivity profiles I shared pictures of before, but also the workers' disutility of labor supply. And so those are time varying. Nothing super special to show you there, but you can just think about they're varying by age and by time now, rather than just varying by age. And you can have those parameters change and have those changes phase in or occur at a specific point in the future. It's not just something that you need to institute in the initial model period. All right, so a lot of flexibility there. I think are going to allow users to really capture a number of different types of policy interventions. In particular, we're thinking about health and environmental policies, but we can think about other types of policy interventions as well, like in education, that now we can, in this cohesive framework of the OG Core model, evaluate the macroeconomic impacts of those. So you can think about now we're allowing for dynamic scores, not just of tax policies, but also of spending policies, things that have effects on education, health, and the environment, and so forth. So we'll have more to come on this. We should be having some papers coming out in the future using these additions to OG Core. We will also try to update the documentation with some examples of how to use these new features. All right, so thanks for tuning in. We hope you find this valuable, and we'll see you back here for the demo day in a couple of weeks.